Okay, so example 3, we're going to do some evaluating of logs. So we're asking ourselves, what is the value of this expression? So example A is log base 5 of 125. And what we really want to think about is if we were to convert this into something that we're more comfortable thinking of. At this point in our math careers, we're more comfortable thinking of things in terms of exponentials. So let's convert this into the base to what power gives us our result. So this we're going to convert to, so we have our base is 5 and our result is 125, and we don't know what this is equal to. So the base of 5 to what power is going to give us 125? Because remember, guys, that the base 2 of some result gives you the exponent. It gives you your exponent. So this is what I want us to think, is think in terms of an exponential. Think the base to what power would give me 125. And when you think about it like that, I mean, it's pretty clear that, well, we know 5 to the third power is 125. So if you were to plug this in a calculator or actually plug it in a computer, if you put log base 5 of 125, the answer is simply just 3. That's an operation that we're performing. Okay, let's see if we can do the same thing. The log base 1/4 of 16. So let's convert that to an exponential. So we keep our base 1/4 to what power gives us 16. Now this is kind of a tricky one, but think about it. If you raise 1/4 to positive number powers, you're going to take 1/4, like if you square 1/4, right, you're going to get 1/4 times 1/4, which is going to give you it's going to give you 1/16, which is a smaller fraction. So you need to go the opposite way, because if you take 1/4 and you raise it to a negative power, then you're going to get away from fractions back into whole numbers. So in this case, you want to raise this to the -2 power. So log base 1/4 of 16 is -2, because when you take the base and you raise it to the exponent, you will get your result here. So when you raise a base to -2 of 1/4 to -2, you will get 16. Okay, let's keep going here. The log base 3 of 0. So we're asking ourselves, 3 to what power will give me 0? Well, if I raise 3 to any negative number, I'm going to get fractions, fractions, fractions. If I raise 3 to 0, anything to the 0 power is 1. And if I raise 3 to positive numbers, I'm going to get bigger and bigger and bigger numbers. So in this case, there's no solution here. This is undefined. So we'll say undefined, or there's no solution. And then D brings up an interesting idea. Okay, so it's log base 2 of 2 to the 8th. So we ask ourselves, 2 to what power would give me 2 to the 8th? And you look at that and you're like, well, wait a minute. 2 to what power gives me 2 to the 8th? Well, the power's got to be 8. So in this case, log base 2 of 2 to the 8th is just 8. But I want to bring you guys back to that idea we talked about in example 1. Remember, log bases and exponential bases that are the same cancel. So whenever you have log base 2 of 2, that cancels and your result is just 8. Or if you had log base 7 of 7 to the 4th power, the 7 bases cancel and you're left with 4. So if we can relate things back, that's why being able to convert between logs and exponentials is so important. Because if we can think of things in terms of exponential forms, we can typically do a lot of evaluating with logs.